In this video, we'll be deriving a general formula for the area of an equilateral triangle. An equilateral triangle is a special triangle in which all three side lengths are equal. We can call this side length for our triangle S. Because all three side lengths are equal, all three interior angles must be equal as well. The sum of the angles in a triangle is always 180 degrees, so each individual angle must be 60 degrees. Now let's get to the formula derivation. The area of a triangle is always equal to the following formula: 1/2 base times height. Now if we try to apply this formula to our triangle, you'll notice that B, the base, is equal to S, our side length, and H, the height of our triangle, is the one unknown. So if we determine what H is, then we'll have a general formula for the area of an equilateral triangle. Let's start by defining what the height of a triangle is. The height of any triangle is the perpendicular distance from one vertex of the triangle to the line containing the other two vertices. So if we draw a line from one vertex of our triangle to the line containing the other two vertices and prove that the angle this green line forms with the base of our triangle is 90 degrees, we've justified that this line is our height. So essentially, our goal for now is to prove that this angle here is 90 degrees. So I've redrawn the part of our figure that we're focused on right now. And an important thing to note here is that the green line I've drawn bisects, or cuts our equilateral triangle in half. We know that this angle must be half of what it originally was, and so it is 30 degrees. This angle over here, nothing has changed, so it remains 60 degrees. And we know the sum of the three interior angles of any triangle must be 180 degrees, making this angle a 90-degree angle. 90 plus 60 is 150, and 150 plus 30 is 180. And so now we prove that this green line is indeed the height of our triangle because it is the perpendicular distance from one vertex of the triangle to the line containing the other two vertexes. All that's left to do now is determine what H is in terms of S, and then we can plug everything into our formula and get our general form. Let's return to the figure on the bottom and start labeling side lengths. We know this side length is S. This has to be S divided by 2 because the green line bisects our triangle, so the length is half of what it originally was, and the only side that's unknown is the height H. Because this is a right angle triangle, we can apply the Pythagorean theorem here to determine what H is. The Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the two shorter legs of the triangle and c is the hypotenuse. Let's call the leg with side length s over 2a, so the formula becomes s over 2 whole squared plus the length of the other leg squared, so h squared, and this is equal to the length of the hypotenuse squared, so in this case, s squared. Expanding this first term out, we get s squared over 4 plus h squared equals s squared. We want to isolate h, so we'll subtract s squared over 4 from both sides. Now we want to isolate h, so we're going to move the s squared over 4 term to the other side, and if we do that, we get h squared equals 3s squared over 4. If you rewrite this as 4s squared over 4, and then subtract s squared over 4 from that, you get 3s squared over 4. Now to solve for h, we simply take the square root of both sides. The square root of h squared is just h, and the square root of our right-hand side is root 3 over 2 times s. Now that we know what the base of our equilateral triangle is, as well as the height, we can derive the formula for its area. And that formula is the area of an equilateral triangle is equal to 1/2 times the base, which we know is s, times the height of our equilateral triangle, which we know is root 3 over 2 times s. We can simplify this a little bit, and what we'd get is s squared times root 3 over 4. And so this is the general form for the area of an equilateral triangle with side length s.